Before I do that, I wanted to introduce the Arrcus team. Of course, we have along with me, Keyur Patel, CTO and co-founder of Arrcus. We have Matt Anderson, who's a senior customer engineer at Arrcus, and Adi Ramadurgam, also a customer engineer at Arrcus.
Who was our next presenter that was up on deck, just in case?
Hey, Tom, that's me, Matt.
Okay. If he doesn't hop back into the next couple of minutes, we may just go ahead with your section, and we may have to pick him up when he comes back.
Yeah, I'm prepared to do that. It looks like Murli and Keyur are both offline, and
okay.
I think they're in the same location, so it's a local network issue for them.
That might be the case. Okay, Matt, why don't we go ahead and pick up where you're at, and then we will, with your section, and then we'll try to get Murli back on whenever he drops back in.
Okay.
All right, if you want to go ahead and share your screen, then we will get rolling with that, and then we will we will pick it up in medias res. Oh, look, it's a demo.
All right. Thank you very much, Tom.
Go ahead and share your screen. Prime image, are we ready to go on, Matt?
My screen should be shared now. Can you see it?
Yes,
we got it.
Okay.
All right, take it away, sir.
All right, great. Thank you very much for the introduction. So while Murli and Keyur come back, they will resume once we're done, or maybe in the middle of it. We'll see. We're going to talk about SRv6. This is segment routing over IPv6 for simple, scalable, and seamless layer 3 overlays. And then after I go over that, my colleague Adi is going to talk a little bit about automating this solution. So for those not familiar with segment routing, it's a network paradigm with functions encoded in the data plane packets. Whether it's MPLS or IPv6, the information about these segment IDs is transmitted over the network using existing control plane protocols like BGP or your IGP, in particular for this demo, ISIS. And with MPLS, it's reusing the existing label field to represent a segment ID. And with SRv6, it's using the existing IPv6 destination address field to represent a segment ID. In addition to that, with MPLS, with the concept of a label stack, with SRv6, there's a concept of an SRH or routing header that contains the other segment IDs that are in the packet to be processed in order. Now, the use cases for this abound, but one that you could think of is network segmentation for, say, a cell site router that needs to provide different service contexts. It could be layer 3 VPN for a large backbone provider. It could be a large enterprise network that's providing some sort of segmentation for guests versus employees. But anything you can use a layer 3 VPN for, you can use this for. And in addition to that, SRv6 has a lot of other use cases that are not even related to VPN by virtue of it being a network instruction. So with ArcOS, our operating system that runs on merchant silicon hardware, you can do both SR-MPLS and SRv6 L3 VPNs. This is shipping. You can do topology independent loop-free alternate or TILFA, including microloop avoidance with SRv6. And this is an optimization in the IGP to make a more resilient solution. And it's simple because you're advertising SIDs in existing protocols. You don't require LDP. If that's existing, you can throw it out. ISIS advertises what are known as prefix and adjacency SIDs, and these are two types of behaviors that I might go into a little bit later. And BGP, which is the focus for this demo, sends the VPN encapsulation SIDs, which are NDT4 and NDT6, and I'll talk about that in detail later. The solution is also scalable because there's no switched path state in the core. There are no label switched paths. And the convergence time is determined by one optimized protocol, in this case ISIS, with no need to synchronize or coordinate two or more protocols. It's also seamless because it works over any IPv6 network. SRv6 packets are IPv6 packets. They have an additional header, but anything that doesn't understand SRv6, it's transparent. And because we use BGP for advertising VPN routes, it uses the same infrastructure that you would have for BGP in your network. So it's very seamless from a deployment standpoint. The demo topology that I'm going to show has a number of ArcOS routers. These are all Broadcom Jericho 2 based from a combination of Quanta and EdgeCore. We also support SRv6, L3 VPNs, and the other functionality on Qumran 2C or Q2C from Broadcom. You can see that there are 3 PEs, PE1, 2, and 3. PE1 and 2 on the left provide a dual homing solution to the customer edge router CE1 on the left. And PE3 on the right provides a single home connection to an Ixia that's acting as a second CE. You'll also notice that P1 and P2 are IPv6 only nodes that are just transiting IPv6 packets for SRv6. And you can see here as well that we're sending bidirectional in these VPNs, V4 and V6 traffic that is carried over this core with an IPv6 header with an SRH in most cases to bring it to the correct VRF and correct table on the egress. You can see the AS numbers as well. That might be useful for reference as we go through the demo. So one more slide before I go into the demo. I mentioned that a segment ID is a sort of network instruction, and you can think of it in that way, in that a packet that's sent to a SID that has a function associated with it determines what behavior is applied. It's not a tunnel per se, but it's a egress behavior that is dictated by the segment ID on the packet. So for example, if a packet arrives at the SID cafe 1100:2::, that is an NDT4 behavior. You can see that in the function column, and you can see that it's going into the network instance CEVRF1 and to the table, the V4 table there, which has this table ID. So autonomically, when the packet is received, it will decapsulate and remove the outer IPv6 header. It will use the correct VRF end table to look up the destination address of the inner packet and then forward it in that VRF as though it had been in that VRF from the beginning. There are other n.dt SIDs that can encapsulate and do lookup and forwarding behaviors in different VRFs, different tables. And there are also other modes for these that determine where segments are popped, whether there's, in the future, a layer 2 lookup or something along those lines. So you can see the flow chart. If the received packet is destined to one of my SIDs, then I apply a SID behavior. The SID itself determines what that behavior is. If there's no SID, local SID in the packet, in the destination of the packet, then it's just a transit packet. It will forward it as usual for IPv6 forwarding. So I'll go ahead and go to the demo now. So for the Ixia portion of this, you can see how this lines up with the topology shown in our slides. We have a site on the left, which has a CE in it. In this case, we're using the Ixia just to put some networks and some routes into that CE and traffic. And then on the right, we have an Ixia that's working as a standalone CE. So it's also running BGP with PE3. And we can see both BGP and BGP over IPv6 sessions configured here. So let's get into the CLI. This is the exciting part here. Let me close. Trying to hide the video. There we go. All right, so I'm going to be switching back and forth because I just have one monitor set up here, but I wanted to show what this looks like on the PE1. So we are currently looking at PE1. This is the top left node here. And we're going to use a command to look at all of the routes in the RIB for CEVRF1. This is the VRF that's facing CE1. We can see that we have a combination of directly connected. Some of these are loopbacks. Some of these are the adjacency, the interface itself to CE1, and the rest are BGP. Some of these are coming from the other PEs in the network that are importing the same route targets, and others are loopbacks for that VRF on other PEs. Now, if we want to look at the BGP sessions in the default VRF, these are going to be the sessions that carry the VPN prefixes. So PE1 has connections to the two P routers. P1 is :10 and P2 is :20. You can see that these BGP sessions, iBGP sessions, are both established with L3 VPN address families being communicated. And then we can see on the other side, facing the CE, that we have two eBGP sessions facing CE1. One of them is for v4 and one of them is for v6. Now, we talked about segment IDs and how these look in the router are determined by the routing protocol clients that are using the segment routing. There is what's called a locator in segment routing. With SRv6, the locator is a v6 prefix. We look at the locator. We can see that it's configured as a /48. And this is out of a block of /32 that all of the routers in the network that are participating use. So if you look at the same command on PE2, you can see that it has Cafe 1000 and then 200 instead of 100. And then PE3, we can see that it has Cafe 1300. So these are all unique /48s. And out of this prefix, out of this block, the SID manager on the router will allocate SIDs for BGP and ISIS and other protocols. And we can see that if we look at the SRv6 local SIDs, that there is a client of a BGP in this case that's allocated two /64s out of that /48. One of them is a DT4, which says decapsulate and look up in the v4 table, and the DT6 decapsulate and look up in the v6 table. And again, these are both for that VRF, CE VRF1. And then there are also end and endx SIDs, which are associated with ISIS generally. You can think of these as sort of like the loopback or the prefix for this node. If a packet is sent to that address, it will go there first, and then there'll be a table lookup. If it's an endx, it's a cross connect after that happens, which will send it out a specific interface, in this case, SWP1 or SWP2. So you can use it for traffic engineering. But what we're going to be focusing on for this demo are the BGP SIDs NDT4 and NDT6. And you can see this on all of these PEs. They all have, out of their unique locator, a combination of NDT4 and NDT6 SIDs allocated that are also advertised with the prefixes in those VRFs, or in those VPNs. So once a router receives information in the VRF about a prefix, in this case, we're going to be looking at 2001 10.9999/64. This is a route that's coming in from CE1 on the left. So CE1 has a subnet on the IXIA. If we look at it here, there's a subnet 10.99.99, actually the v6 side. 2001 10.99.99 : and then it has 100 through 109. So we can see that in our sort of summary advertisement from that CE. This is then exported into the default VRF as an L3 VPN v6 route that will be advertised with a next hop and a service SID. Now you'll notice that the service SID is associated with the locator for PE1. So when PE1 advertises this route to the core and it's received by PE2 and PE3, we can look at that here. So PE3. One moment. We can see that it's received the same route from PE1, and it has these attributes, these special attributes that define the endpoint behavior and the service SID, along with the next hop that tell it what SID to use. In this case, if you recall, this 1100::3 or :3 is the NDT6 SID on PE1. So now PE3 knows how to send a packet over the VPN to get to PE1 and to get into the specific VRF and the specific v6 table in that VRF to reach this prefix on CE1. So we can do a VRF ping to verify this connectivity. And And I will also do a IXIA traffic demo. So what we're doing now is pinging between the VRF1 on PE1 on the left toward a prefix that's in the VRF that's importing that on the right on PE3. And we are getting packets responded to. Now, what you don't see in this ping is that in the middle of the network, there's an SRH being added, and it's using SRv6 to get to PE3. But if you capture this using something like TCP Dump, which is available on our systems, you can see that these requests and replies look like this. So the echo request is represented with an IPv6 header first and then an IPv4. The IPv4, these are the IPs that we used in the ping command. The destination is 192.168.13.1. The source is 11.1. But today, where the destination is the SID. It's cafe 1000:300:2::, which is on PE3 on the right. We can see that there's an SRH that has this single address in it. And what the router will do is it will receive this, decapsulate, look it up, realize this is a loopback in CEVRF1, and then it's going to do a reply. Now the reply needs to go back to that loopback that's in VRF1 on PE1 on the end. In order to do that, it knows that it needs to add a SID as well in the reverse direction. In this case, it's the SID on PE1, cafe 1000:100:2. And so that rounds out the sort of the round trip path that's taken by ping. Again, this is from PE1 inside the VRF to PE3 inside the VRF. And this applies as well if the CE were pinging a prefix on another CE. So let me cover the traffic now. Again, the IXIA setup has a left and right port. One side is advertising some subnets into, well, it's not advertising, it has some subnets, and they're being distributed into the CE BGP here. On the right side, it's running BGP and it's advertising a number of routes out of pools configured here. So we have a range of 20 addresses starting at 200.1 for v4 and a range of 20 addresses starting at 3000, et cetera here. We can see these as well if we run the show command. For instance, so we can see 200.1 prefixes for v4 and the SID that's associated with those, how to reach it. And then for v6, we can see the 3000 colon prefixes that are, again, these PE. And it's telling you that to reach this VPN prefix that you need to use the SID. You might want to, in more complex situations, know, what SID list is going to be added to this packet if there were multiple SIDs, and you could do that with this this tunnel command. You can look as well at your local SIDs and see what are going to be advertised on your own routes that are going out, depending on which VRF they were received in or which VRF they've been exported from to the default VRF. If you're doing anything with ISIS for segment routing, and this is a little bit different topic than what we're doing with BGP. You can see here that in ISIS, in the TLVs and the LSPs that are being received, that they're a combination of end and endx SIDs. So the endx SIDs allow you to send a packet to a core node and have it go out of a specific interface on that core node. So this is useful for traffic engineering, for example. You can see here that P1, you can just sort of almost like a menu. If you want to send a packet that goes to P1 and then goes out the interface toward P2, you just put the SID listed here on the packet. This might be something that's communicated with BGP link state to a controller. That controller might create an SR policy that is injected back into the head end based on some business logic or some rules or coloring that's required for the treatment of that traffic. These SIDs are also used for TILFA and microloop avoidance to guarantee that a packet going on a protected path won't be looped back to the destination and won't experience microloops along the way when there's a topology change, although we're not demoing that here. So one more thing I wanted to show is our analytics platform.
Quick question on that.
Yeah, please go ahead.
So on the SID side, can you also use that for NFV? So you can do an NFV insertion if you wanted to by basically pointing it to that specific SID. You could have an NFV function that you drop into and then pop back out.
Yeah, possibly. If you have a server connected on that interface or on a specific interface that you want to receive those NFV routed packets, that could be done as well. Yeah. One of the great things about SRv6 is that it works over IPv6, so you don't have to have ubiquitous end-to-end deployment of the SRv6 capability. If you have it in enough places that the NCAP, DCAP, and any sort of TE logic is done at the nodes that support it, then it'll work, even if you don't have it ubiquitously deployed.
Right. So you could just have a v6 endpoint. It doesn't even know the difference because it doesn't know that you're running SRv6. It doesn't need to know about that portion at all, right? It just needs to run.
Yeah. As long as your VNF for your function chain downstream of that knows what to do with the SRv6, then you're good.
Right.
Yep.
Yeah. Okay.
Yep. Any other questions before I cover just briefly our analytics?
Yeah, what path computation element kind of controllers is supported by Arrcus?
Yeah, so we don't have a PCE at this time. However, with the ability to integrate with some of our netconf and automation packages, which Adi will talk about, some of the integration options are there. If you're looking specifically for BGP link state or using BGP to communicate SR policies or PSEP, I believe that's all roadmap for us at this point. But again, the integration options are there if you have the flexibility to work with one of the interfaces that we have now.
Can I add one point here? I'm sorry, by the way, for the disconnection on my side. But one of the key things I also want to add, Carl, there is that there's standards interfaces. The APIs are standards. It's open config, netconf based, open config based models over netconf, and so essentially, existing controllers that support PSEP can essentially have an easy plugin as well, in addition to the workflow stuff that Adi is going to show.
Great, thanks, guys.
That's the beauty of this approach, is that it scales very easily across all of any kind of environment. We don't make a religious requirement about requiring our own controllers or our own set of solutions.
Yeah, thanks, Murli. So just one more thing before I hand it over to Adi. So we have a platform known as ArcIQ. Now, ArcIQ is an analytics and deep insight platform. This has a web interface that allows you to look at telemetry information that's come from your network. We stream JSON over Kafka for most of this data, although we are also able to do telemetry streams for BGP using BGP. And we have other information as well, like SFlow, and we're adding to this over time. For segment routing for SRv6, one of the useful things that this can do is show you some of the CLI information that I was looking at as far as SIDs go in an easier to access format potentially. So the five routers in the topology, 3 PEs and 2 P routers, are all currently streaming telemetry to ArcIQ. And if we want to look at the information for, say, PE1, we have all the platform information here, all the information about software version, hardware, system information. And in the segment routing IPv6 dashboard, we can also see what locator is configured. And this is that CAFE 1100/48, as well as some fields is known as locator node and function length, which apply to what range of this address is used for SRv6 function and arguments. And then the local segment IDs that have been allocated by our SID manager. And you can see here again the NDT4, DT6 for VRF1 and VRF2, as well as the ISIS or IGP associated SIDs and NDEX. In addition to that, we have paths for NDEX that show which interface will be taken for that NDEX SID.
Hey, Matt, this is Jeremy. I got a quick question for you. Is ArcIQ also a service provisioning product, or is it exclusively?
ArcIQ is primarily visibility. And so for the most part, it's a read-only approach. We have other information, like you can look at the discovered topology from the IGP and sort of visualize this. All this, again, is not pre-populated. This all comes from real-time telemetry. We have LLDP topology and BGP topology as well. And again, you can see here that we have prefix looking glasses that can look at all these prefixes in the network and show the attributes, next hops. Security includes ROV, origin validation. But to answer your question, yeah, it's primarily visibility.
So if I'm presuming Arrcus and this, this kind of technology is geared towards service providers for the most part.
Not exclusively, but that's the focus of this demo, I would say. Yeah.
Yeah, I mean, so it seems to me, and I'm not a service provider guy, but I used to sell to them, that the service provisioning and service monitoring kind of go hand in glove. So I'm kind of curious what, when your customers ask about how do we provision these services and roll them out across a network, what answer do you give them?
Yeah, well, I mean, the typical answer is it's an integration exercise with your automation systems. And in the case of a lot of our cloud service provider, hyperscaler customers, they have their own preferred way to automate, their own preferred, whether they're using Ansible and templating that way, or whether they're using netconf natively, or if they're doing Python, we have something called ArcAPI that allows them to interface with our config and our operational state in a programmatic way there. As far as ArcIQ being a provisioning tool, I agree, usually they are hand in hand, but we have decided to focus on deep insight and visibility to help customers find issues, find problems, rather than accelerate provisioning and accelerate config management, which are definitely hard problems worthy of solving, but it's not what we're solving with ArcIQ at this moment. And Murli, if you wanted to add anything on that.
Yeah, no, I think you nailed all the points there. But Jeremy, I think the key point we wanted to mention is that most of our customers actually have existing, reiterating the point that Matt made, have either existing proprietary service provisioning environments already baked in. They ask for open standard programmatic APIs, or they have workflow software automation systems like the stuff that Matt mentioned. So Ansible, of course, is very popular, and Terraform in many environments as well. And so, yeah, our approach has been that providing deep visibility and analytics gives us brings a differentiated value to how they operate their environments day 2, day 3. That's one of the biggest gaps in infrastructure, especially in the edge and backbone, which is where a lot of these use cases are going to be deployed. And so that's where we wanted to focus first. Conceptually, sorry.
I'm sorry.
I was just going to say conceptually, clearly, ArcIQ could be extended to add provisioning support as well. In fact, there was a lot of discussion internally as well at the initial days before when ArcIQ was launched like a couple of years ago. But we decided to double down on visibility and insights because that's what the big problem is right now for operations teams.
How would you characterize your market segment? I mean, is it mostly service providers or your customers that have this technology in production? How would you kind of describe your market?
Yeah, that's the. Unfortunately, my presentation will cover that, and that kind of got disconnected. But fundamentally, our pitch, our approach has also been that the traditional silos, as I was just saying at the start of my presentation earlier, was that the traditional notion of silos, where you had a data center networking solution, you have a backbone solution, or you have a campus solution, those are completely being obliterated, because in fact, edge, the computer is moving closer and closer to the edge. So essentially, merchant silicon combined with with how edge is kind of emerging has made software solutions span across all of these environments. So that's why, if I could take a few more minutes, Matt, essentially, when we, right from the day we launched, we have said that software-powered network transformation has a few key tenets. One is routing. It's going to be routing centric, whether it's in the data center top of rack or whether it's in the backbone and the edge. The other thing is we have built a very strong data path adaptation layer, what we call DPAL, or an abstraction layer in common parlance, that essentially allows us to port to any kind of switch, router, and even smart server environments. So that's why we announced, the XGS-based switching family, Trident 3, Tomahawk 3, all of that generation. But at the same time, we have support for Jericho 2, which is what this demo shows, Qumran 2C, which is the edge-centric solution. So our customer base spans all of these. In fact, we have customer bases across all of these environments, as well as the transformative enterprise environments, plus CSPs, service providers as well. I don't know if that answered your question, but I wanted to give the context of why we have customers across the board. In fact, that is the key differentiator.
I understand the why. I think that why is almost table stakes. In today's world, everybody says, this is our operating system. It has a great API. It's one operating system across all of our devices, and that's our differentiator. And I'm trying to understand how Arrcus differentiates, in that table stakes kind of dialogue, because I'm kind of an operating system nerd. I'm a network automation nerd. I love these technologies, but I'm trying to rationalize why somebody would choose to use Arrcus, versus some other network operating system, whether it's from a traditional vendor or whether it's Sonic. What is special about Arrcus that makes somebody say, I got to buy that versus something else?
First principles based approach to building software. The traditional incumbents have had a 30-year run building, as I mentioned earlier, software that essentially built software bloat, one on top of the other, built software that is very, very siloed, very, very pin specific, place and network specific. Although you said that everybody says table stakes, even the legacy incumbents today have different OSs for different parts of their network. I mean, I know I worked in those environments. Most of us have worked in those environments. Essentially, you had a different operating system, different models building the underneath of those operating systems. So it's never been the case that there is a common software. Then the other end of the spectrum for the incumbents, for the other end of the spectrum, essentially you have these, you've had startups. We're not the first that has talked about networking software, but what has happened is the prior efforts involved open source software, primarily Quagga FRR, and other variants of that. You kind of glue it together and say, hey, I'm going to use this for a data center. And that's why those solutions were very, very data center specific. What we're saying is that our network software, not that it's just deployable on any device, we're saying that it can be deployed in any kind of environment, whether that's a switching data center environment, whether that's in the backbone as a router, or whether that's at the edge, supporting 5G use cases. In fact, the demo that Matt is showing today is primarily a 5G edge access use case, where essentially you're simplifying all of the complex MPLS layers that you have, LDP, RSVP, underneath MPLS transport, removing all of those and just having plain simple SR. So what we're saying is networking it's not just about a device A and device B. Networking no longer is recognizing the different OSs for different parts of the network. whether a data center X OS or a backbone Y OS. That's the big point from the same vendor.
Yeah. I'll
so
call
that
out
is the
as
big.
well, Murli, and related to that, the boundaries in a network and the roles that are defined. For instance, in the past, you would have a PE that would be, 3 letters, 4 numbers from the vendor, and then you'd have a P that is probably not the same thing because they don't position it there, where you're buying a different silicon system, a different form factor, a whole different product line for your core. We don't have that distinction in a lot of ways, and because of that flexibility, if you wanted to deploy the core with Arrcus J2, you could, and then in the future you wanted to turn it into a PE and make it an edge location or put servers, compute, customers there, you could very easily do that, both from a feature functionality, hardware capability, but also from a protocol simplicity standpoint, that we're not creating these sort of artificial boundaries between what's edge, what's core. So this kind of ubiquity was something that we really gravitated to with SRv6 and with segment routing in general. Beyond the fact that it's clearly the next gen approach for delivering these types of network services, and I think that that's a big differentiator as well if you compare us with some others in the marketplace.
So I think what you're saying, I mean, I'm kind of translating what you're saying, but I think what you're saying is if I'm the kind of company that wants to deploy SRv6 because of the reasons of what we're trying to achieve, then Arrcus is a really great choice for, the reasons you've described. But for general purpose networking, like, in the network that I manage, parts of it are that look and feel like a service provider. Many parts of it look like a data center. Many parts of it look like a campus. They have aspects of power over Ethernet, the whole 9 yards. Like we do all of it. And we've used operating systems that kind of touch the boxes that live at every part of the network, but we don't use SRv6, for whatever reason. So is Arrcus's, kind of differentiator the fact that it does SRv6 better than anybody else, and it's easier to manage and easier to roll out and troubleshoot?
There are 2 aspects to that. Just real quick.
Go ahead, Matt.
Yeah, I was just going to say that the first aspect of that is what's the differentiator in terms of being able to cover enterprise, switching closet, PoE, data center, IP clo, et cetera. We cover all of that. We have platforms that are geared towards Tor and 1 gig E. We have platforms that are geared toward 100 gig E, future 400 gig E data center spine. We have XGS and DNX if you're into the Broadcom chip nomenclature. What you're seeing today is just a portion of our portfolio, and there's a lot of other stuff that's not being presented. The second part of that was what's the differentiator specifically for SRv6. And I think that the takeaway you can have here is that we can do it on merchant silicon as an ODM built box that can, at the price points that you get with that approach, do very, very feature rich SRv6 with service delivery. Murli?
Yeah, no, I'll let KU speak, but just give me, Jeremy, why don't we touch back? I have specific answers to your questions, including our solutions for the data center, for the campus, and so on. I have slides for that. We'll talk about it then as well. Okay.
Okay. So why don't we wrap up the demo? I think we have one more topic, and then Murli, since you only had maybe 5-10 minutes to present, you will have the balance of the time, and there's a lot that you have to cover as well, right? So I'll hand it over to Adi.
Okay.
Thank you. Can you guys see my screen? Any questions?
This is kind of going back, I think, a little bit to the earlier SRv6 stuff, but didn't have a good chance to ask it then, so I'll ask it now. So when it comes to SR-MPLS and SRv6 and label depth and how big of a stack you can have, what's the longest ERO that you can really do with Arrcus? And, what are the limitations there on the Arrcus platform?
Okay.
Yeah, Adi, if you remember the specific label depth or SRH size, I don't recall, but there are a couple of aspects there. The first is what's the use case. So if you're creating an ERO for maybe disjoint paths that are manually provisioned, then you could very quickly exceed the stack depth or the SRH size limits. If, on the other hand, you're trying to determine the maximum number of SIDs that are required to achieve, say, TI-LFA coverage in a backbone, there's been a lot of research out there that shows that in most cases, you don't need more than a few, and in many cases, you need only one. So, Adi, do you recall the exact specifications there? I don't know off the top of my head what those limits were.
So the depth, in general, yeah, I don't recall the exact number, but it also kind of depends on the hardware used in certain cases, because that's where the encapsulation is being done. And as Matt has mentioned, there's been a thorough research on the number of SRH headers that you need for each packet, and it's quite handful. It's not much, but yeah.
And
yeah, it's going to be topology as well. Yep.
Okay, and so do you support binding SIDs and stuff for joining together some of that stuff?
I believe that's doing binding SIDs and creating SR policies is something that we have on our sort of near to medium term roadmap. It's something that has being able to statically configure it is something that we could probably do pretty quickly if you know what the SIDs are and you just want to configure SID 1, SID 2, SID 3. But we're going to want to do it in such a way that it's more usable than that, which means being able to take SR policies that are specified via connection to a controller, BGP, or even SR policies that are defined in terms of endpoints, colors, and constraints in a policy language like some of the RFC or IETF drafts are showing. The SR policy draft just went to working group last call, so you can read that. That's approaching sort of finality. But yeah, short answer to the question is we don't support binding SID yet in that sense.
And you mentioned PC. I know that Arrcus doesn't have a PC, but you mentioned supporting connectivity to PCs and things like BGP-LS. What about PSEP? Is that supported? Or is that coming?
I don't believe we support PSEP now.
Okay,
but it's coming. It's on the roadmap.
Mm-hmm.
I mean, we're going customer use case by use case, and so far for the use cases that actually the demo kind of alluded to, it wasn't required. But that's something that's being added as we speak.
Yeah, we're doing.
The other thing I want to highlight is the SRTE is also another capability the architecture supports, and so essentially that's built in as well. Chris.
Okay. And I got a question from somebody actually here who's not here. What about seamless BFD and inside like of an LSP? Is that supported?
BFD is, yes. KU, do you want to add anything to that?
We do support single hop BFD for sure.
Including hardware offload on this platform. Yep.
Any other questions? All right, very good. No, Murali, just to double check, do you want to finish out your section from where you got cut off, or do we have another demo that we want to do?
No, I think I'll continue from where I got cut off.
Okay, let's do that.
Just because we have about 25 minutes. I think we're done with the demos. Maybe Matt, do you want to, while I bring up the presentation, do you want to summarize overall the bigger context ones of the demo, just because of a lot of the questions that came in as well?
Yeah, I mean, to summarize in terms of scalable, seamless, in terms of simple, SRv6 for L3 VPN by virtue of using existing routing protocols that are used for IP, by virtue of requiring no state signaling in the core, and having convergence time on the shoulders of one protocol rather than multiple protocols, and that protocol being fairly optimized. And in terms of it being transparent to IPv6 only nodes, and using the great BGP for advertisement of VPN routes, we're using a lot of existing infrastructure, a lot of existing capabilities, as well as making something that's future-proof for an IP infrastructure a la 5G, which really is IP everywhere. And so, again, to this use case of a cell site or edge compute with MSC, you have only to deploy IPv6 into your RAN and selectively deploy SRv6 where it's needed to provide VPN overlay, to provide policy control, TE, and other aspects of your mobile deployment or your edge compute deployment. And a lot of these same capabilities extend into wired access and general internet and network edge. So, with SRv6 on ArcOS with Arrcus, you are getting something that's next gen, but not in such a way that we're reinventing the wheel. We're using a lot of what's good about IP, IPv6, and the existing control planes that are out there.
One quick question, Matt. I know I saw ISIS by itself in the ArcIQ, and you used ISIS for the demo. I was just wondering if we could have done the same thing with OSPF version 3 on ArcOS.
So doing SRv6 and SID with OSPF v3, I don't believe we support yet, but that is roadmap. Yeah. And
I mean, fundamentally, from an architecture point of view, it's seamless. I mean, it's essentially changing a control plane.
Yep.
I mean, it's just that most of the deployments that we've seen for segment routing have been over the ISIS IGP.
Okay, thank you.
But yeah, as you rightly pointed out,
I will point out though that if you have an OSPF v3 core, you can still do SRv6 L3 VPN over that core. That's not a problem at all. It's just a matter of having IPv6 end-to-end connectivity to be able to deploy the solution.
Since we're mentioning various protocols, I'll ask a question that I kind of have about Arrcus in general and with ArcOS. Where's the routing stack come from? Is that something built entirely in-house? Is that FRR? Is it IPI? And et cetera, et cetera.
Kayer?
I think, Kayer, why don't you take it away?
Yeah. I just want to answer something real quick before I answer that. I hope you don't mind. Seamless BFD is supported. I goofed up when I said a single hop BFD. Somebody did ask also about SIDs, and you could do 4 SIDs in one go with Jericho 2, and there is a hardware support actually with some tweaking. You could go up to 9 SIDs. This is an important point I want to leave. Sorry.
So real quick, speaking of standards based, and you mentioned IPv6. From a management standpoint, can you support IPv6 only for management? I know that sometimes dual stack works great, but IPv6 only can get a little hairy.
Yes, absolutely. Okay, did you want to add anything?
We have actually gone through evaluation phase and are close to deployment with a customer that's doing it that way.
Yeah, IPv6 only and designed to scale again.
But I want to say thank you very much to the Arrcus team for the great overview of your operating system and making sure that we all had a great understanding of it. As soon as I saw SRv6 pop up on the slide, I knew that Ed Horley and Chris Cummings were going to be super excited. So thank you very much for that. We're going to go ahead and close the stream out for today. We really appreciate everybody tuning in, following along with us. We had some stream hiccups earlier in the day, so we'll make sure that those get ironed out. We'll be back tomorrow morning at 8 a.m. Pacific time with day 2 of Networking Field Day. You're not going to want to miss it. If you want to find out who's presenting, head over to our website if you're not already there, techfieldday.com. Click on the link for the event, and you can get tomorrow's schedule and Fridays as well. So you can make sure to tell your boss you're going to be busy watching all of the great Networking Field Day content. But for now, for the delegates, for myself, and for our great presenters, we're going to call it a day. We'll see you bright and early in the morning.